This is the Digging for Truth podcast, presented by the Associates for Biblical Research, demonstrating the historical reliability of the Bible through archaeological and biblical research.
Is the conventional history of the Earth scientifically secure? You know, the one that says the Earth is like 5 billion years old, and all life evolved from single-cell organisms into plants, animals, and humans over hundreds of millions of years? Well, Dr. John Walton was wondering that same question, so he wrote a book about it called Compact Time, Radiocarbon Dating, and the Case for a Young Earth, and he's here today to talk about it. Dr. Walton is a professional chemist with over 30 years of academic research experience in organic chemistry, specializing in molecular timing and dynamics. And his work has earned international recognition, including a Royal Society of Chemistry Medal, and he's a longtime professor of chemistry at St. Andrews University in Scotland.
Dr. Walton, welcome to Digging for Truth. It's great to have you on the Digging for Truth podcast.
Thank you very much, Henry. Thank you for inviting me. It's a pleasure to be with you again.
Yes, I'm very, very happy to have you on. We are going to be talking about your book, Compact Time. And boy, it's compacted with a lot of great information. But before we delve into the specifics of the book, and there's a lot to talk about, I'd like you to expand a little bit on your scientific background. Tell us a little bit more about your experience in the world of organic chemistry.
Okay, I'll be glad to. As you said, I live in St. Andrews, the home of golf, not far from the sea, and I've been a prof at St. Andrews University for a good many years now. I've got a couple of doctorates in chemistry. 2 years ago, I became emeritus professor at St. Andrews University. My research there was about developing more environmentally friendly synthetic methods, particularly penicillin-type antibiotic compounds, also quinazoline compounds that are useful agents against lymphomas and related cancer agents. And I also investigated carotene and xanthophyll derivatives, again, as anti-cancer agents. But I also carried out research, as you mentioned, on several methods of timing chemical processes, particularly free radical reactions. And that included a spectroscopic method known as electron paramagnetic resonance. I've published over 300 papers in refereed journals on these topics. And again, I think you mentioned that I was elected to the Royal Society of Edinburgh, which is Scotland's National Academy. So that's really my background. I'm emeritus now rather than so active in research.
Well, that's excellent. In the earlier introduction in your book, you talk about this experience you have in organic chemistry. One of the things that you mention is sort of the experience that's necessary regarding sort of time. I think you mentioned molecular clocks. And so I think you state this to maybe disarm the person who thinks, well, how is this guy qualified to talk about deep time, right? You kind of mentioned, well, I have some experience in dealing with, clocks in nature, if you want to say it that way.
Yes.
In dealing with that, obviously the book expands into areas that are different than that. So tell us a little bit about your thoughts, why you wanted to deal with the question of deep time, and why did you write Compact Time?
Yes. Yes, you're right. I did have quite a bit of experience of particularly timing methods for chemical reactions, and radiocarbon dating does enter into that to some extent because of the phenomenon of radioactivity. But I think, most of us, certainly in the UK, have had the conventional deep time evolution story of millions and billions of years, molecules to man evolution. It was pumped into us at school, at university, and continually by the media. We've been so schooled and doctored by decades of deep time propaganda. As soon as we see a rock or a stratum, we think millions of years, more or less automatically. But I think various dramatic events in the last few decades started me rethinking about this. For example, Surtsey Island in the North Atlantic, just off Iceland, it emerged volcanically in just a few months, complete with canyons, gullies, beaches, rounded pebbles, features that we'd been told took hundreds of thousands of years to form. And then there was the eruption of Mount St. Helens back in the 1980s, massive amounts of crustal change, very short time. The tsunami at Tohoku off Japan, then the discovery of turbidites, rapid underwater flows of sediment. They deposited huge portions of the geological column just in hours. So many geological features actually form rapidly rather than millions of years as we'd been taught. And this made me think that there was a need to re-examine dating methods of rocks and fossils. Of course, there are lots of creationist books about these, but these usually take Genesis as the starting point and relate everything else to that. Now, I've huge respect for Genesis, but I wanted to re-examine from a scientific background, that sort of standpoint. Right for those who know little about the Bible or have been taught it's a lot of unreliable folk tales. I wanted a book that would help secular people to re-evaluate Genesis and hence Christian faith. And my science research, I felt anyway, gave me expertise in timing methods in chemistry, so I seem to have a good background to re-examine timing methods in the earth sciences. I did that, and Compact Time really is the book that I wrote as a result of that.
Yeah, it's interesting. We'll see how you delve into the areas where you're really in your wheelhouse, your expertise, right? In terms of, we're going to get to this, DNA and pliable organic materials found in dinosaur bones and other things and other creatures from the past that are allegedly long ages. We'll talk about, you're going to talk about the specifics of that. But it's interesting too, because you can take, even though like you're not an expert in radiocarbon dating per se, your scientific experience with methodology and understanding the rigors of the scientific method are really incisive in this book. And one of the things that you point out is sort of the lack of methodological rigor in some of these, what you call soft sciences. And combined with that is sort of the assumption of naturalism, as sort of as the foundational starting point for these scientific endeavors, especially in these areas of origins. Could you expand on that a little bit, Dr. Walton?
Yes, indeed. Naturalism is the idea that only natural forces and laws operate in the universe. And of course, in their research, scientists look for regularities and natural laws. But some philosophers and many scientists want to take it beyond that, beyond just a mode of operation, to claim that everything is material. There's no supernatural and no God. But elevating science relationships as universal, unbreakable, eternal laws, that really overstates what they represent. They're actually just limited partial descriptions of regularities in nature. They don't dictate what must happen. They just describe normal, undisturbed outcomes. Science can't prove there's nothing beyond the material. And science can't explain, obviously, where these regularities and relationships came from in the first place, or why do they take those particular forms and not something else. So that's the problem of naturalism, and it does tend, as you say, to be a basic assumption that's made by many scientists. That's not explained very often in their write-ups. And also, we need to recognize that there's a big difference between soft and hard sciences. There are the soft historical type sciences, and that's most evolutionary biology, and much descriptive earth scientists. And these rely on imaginative scenarios like, fish crawling out of water, developing lungs, evolving into amphibians, or maybe reptile scales turning into feathers, or gigantic windstorms scouring hundreds of miles of rock surfaces flat. Scenarios that have no backing from experimental or laboratory or field observations. they're very soft science. And on the other hand, of course, there are the hard sciences that are backed by lab experiments, mathematical formalism, subjects like physics and chemistry. And when it comes to the soft sciences, there's a great deal of room for doubt and skepticism about any consensus. Don't be fooled by the label science, because it doesn't mean the same in these areas as it does in physics and chemistry and the other parts of these sciences that are hard science.
Yeah, it's interesting. You have a great quote in your book. I'm paraphrasing it, something like, if you think that science is settled truth, well, you're wrong. I think it was Richard Feynman or something like that. I'm loosely paraphrasing the quote. You put some great quotes at the beginning of each chapter from scientists. It's interesting. You draw upon it's not just Christians, but mostly secular scientists to sort of illustrate the point, right, Dr. Walton?
Yes, indeed. Yes, I enjoy those quotes when I find them myself, and also when I read them on other people's work.
Yeah, it's interesting. They're in their more rigorous moments, the naturalist scientists, secular atheist scientists, you'll get more of the truth about what they understand the limitations of knowledge and science, and how tentative the whole scientific enterprise is and how changing it is. I mean, just when you think about the history of science, you go back 100 years. I mean, like, the things that people thought 100 years ago seemed reasonable, and now we look back on them and we realize, well, that 99% of that is out to lunch,
Absolutely,
so that often gets forgotten. The age we live in seems to be the age we think we've arrived with our knowledge.
Yes.
Right.
Sciences have what's called a half-life, don't they? And in chemistry, the half-life of facts is only about 7 or 8 years. And in computing and sciences like that, the half-life of facts again is only 1 or 2 years. In theology, of course, it's much longer, 50 years or something like that. There's actually a book about this very subject.
Yeah. We experienced that turning over in technology. That's for sure. As soon as I get a phone that I feel like is up to speed, as soon as I start learning how to use it, I'm already behind.
Yeah.
That shows you the pace of that. Now, a point that you make in the book in the beginning is, look, you admit you come from a Christian conservative perspective, and I think you're trying to sort of cut off the accusation of you're biased and these naturalist scientists aren't. I think you phrase it something like, my perspective is just as susceptible to bias as anybody else is, but it's not to say that I'm biased and they're not. Maybe talk about that a little bit.
Yeah, definitely. That's very much the case. It will certainly be the case that I have that kind of a bias. I mean, all our brains, there's a cognitive bias called confirmation bias. And it's a brain process that we're all subject to. It's our tendency to pay attention to, accept, remember, believe evidence that supports our beliefs, the ones that we already hold, and that's particularly true of our worldview. And then we tend to ignore, discount, deny, forget things that don't agree with our cherished beliefs. As many scientific studies have confirmed the reality of that bias. I probably don't need to mention any of them, but it's certainly the reason that double-blind tests are absolutely essential when verifying new medicines and pharmaceuticals. And scientists are just as susceptible to confirmation bias as religious people or to ordinary man in the street. There's no reason to believe that scientists are a more detached or are immune to confirmation bias and related things. And I think the bias causes particular problems when it comes to dating fossils and rocks from the geological column, because dates that conform with the prestigious geological column, the accepted dates, those are the ones that get accepted. And that if they don't conform, they tend to be discarded, ignored, or explained away in some way. It would indeed be good to introduce double-blind studies into radiometric dating methods of rocks and fossils. as far as I know, that's never done.
Yeah, you make the point and document quite well in the book of instances where it really seems to come down to the geologic column as a general rule, and it's the conventional understanding of the dates dictates what data is accepted and what data is thrown out.
Yes.
So what you're suggesting in the book is when we do radiometric dating where we get hundreds of millions or even billions of years dates, that should be completely double-blind studies. Like you almost shouldn't be talking about what geologic column it comes from. If these methods are truly that reliable, then we shouldn't have to throw out what we call discordant dates.
Yeah.
Right? Is it? I mean, that's
spot on. Yeah.
Not the kind of rigor that you have in your experience in doing organic chemistry.
Yeah. You're absolutely spot on there. I think in many instances as well, discordant dates do come up. In fact, there's a book by John Woodmorap setting out dozens, in fact, hundreds and hundreds of instances where discordant dates were obtained and just explained away in some way or other.
Yeah. So this leads us to what I observe, I think, is the core of your book, although there's many aspects to it that are very helpful. One of the things that you spell out here in documenting is this is so interesting to me. I'm so fascinated with this, and partly because of being involved with archaeology, we deal with carbon-14 dating as well. So the presence of carbon-14 in the geologic column in places where the conventional dates are millions of years, and you point out in many cases how the other methods, radiometric dating, have all kinds of discordant dates and all kinds of problems. Maybe expand on some of that. Go whatever way you would like.
Yeah. Okay. Maybe I'll say a bit first about why I think that radiocarbon dating is more reliable. That's
Sure.
because the conventional radiometric methods that have been used for deep time rely on metals like uranium, lead, potassium, argon, rubidium, strontium, samarium, neodymium. They're all metals that have extremely long half-lives. By the very fact that they're metals, they make ionic bonds. So they give polar minerals that are more or less soluble in the highly polar groundwater. The minerals are polar, so they're soluble to some extent, or some of them very soluble, others sparingly soluble, in groundwater. So they're easily leached out and redistributed by the groundwater that circulates through the igneous rocks. But radiometric dating relies on the minerals remaining in place where they are for millions of years.
Yes.
Otherwise, the amounts measured are going to give the wrong dates. Now, on the other hand, it's a property of the element carbon that it makes mostly covalent bonds that are non-polar. So carbon compounds tend to be insoluble in water. And I'm thinking of materials like bone and wood and oil and gas and coal. The carbon they contain remains where it is. It doesn't leach away in groundwater because it's non-polar. So the results would be more reliable as a result of that. Then in radiocarbon dating, it's the actual fossil or the specimen that's analyzed and dated, that the bone or whatever. Whereas in uranium, lead, potassium, argon, it's volcanic layers above and below the fossil that have to be dated. So this introduces room for more error. You're just looking at layers above and below. And then thirdly, of course, the radiocarbon method has been tested thousands of times with specimens of known age, and it's proven to be reliable back to about 1000 BC or thereabouts. Whereas the other radiometric methods, they failed repeatedly with rocks of known age. Rocks are volcanically formed. They formed in historic times, and they've been tested with potassium, argon, uranium, lead, strontium, rubidium, and so on, and they give wrong dates of millions to hundreds of millions of years. Why trust methods then for unknown rocks? So these are, I think, three good reasons for believing that carbon's inherently a better, more reliable basis for geological dating. Well, of course, the fascinating thing about radiocarbon is that it has a comparatively short half-life, only 5,730 years. So after about 10 half-lives, 57,300 years, it's all virtually gone. It's decayed away after 10 half-life years. So if dinosaur fossils were really 66 million years old, then any radiocarbon, any carbon that they originally contained, radiocarbon, would all have decayed completely away, because that's much, much longer than 10 half-lives. So they contain no detectable radiocarbon. And modern accelerator mass spectrometer equipment is sensitive enough to just about detect a radiocarbon in specimens back to ages beyond, a little bit beyond 60,000 years ago. Before that, none should be detectable. Any rock or fossil that originally contained carbon that's older than this should have no detectable carbon-14 or radiocarbon. So most of the geologic column should be carbon-14 silent, dead, if deep time is correct. And I think you were hinting at the fact that many laboratories from different countries have reported finding significant amounts of radiocarbon in specimens from everywhere in the geological column. That's from samples like wood, coal, anthracite, graphite, fossil bones, marble, calcite, natural gas. They all show easily measurable amounts of radiocarbon. There was a review, Dr. Paul Geim published a review with 70 such reports in it, all from the academic radiocarbon literature, all specimens from throughout the geological column, amounts of radiocarbon well above instrumental background, from about 0.5 to 0.1% modern carbon, which is well above the background. Conventional dating converts these amounts into young ages in the range of about 44 to 57,000 years ago. Now, conventional scientists also claim that this measured radiocarbon is actually contamination. Could this be true? Lots of different sources of contamination have been very carefully examined. The spectrometer background, that's known, that can be ruled out. What about during sample preparation? Yes, some contamination can get in during sample preparation, but it's too minor to explain the amounts that are being found. What about contamination while the fossils are in the ground then? Well, because radiocarbon has such a short half-life, it would have to be recent on geological timescale, or repeating itself over millions of years. And then also this kind of contamination should vary with the depth of the sample and with the depth of the sample within the rock itself. And the quantities of radiocarbon have been found to be independent of both these factors. It's been suggested that there may be neutron fluxes in the ground that would affect this. But of course, neutron fluxes would affect other radiometric dating methods as well. So if carbon-14 were contaminated, right, so would potassium argon and uranium lead, because they're just as likely to capture neutrons as carbon, in fact, probably more likely. So there's no genuine explanation of where this contamination comes from, why it's so widespread everywhere throughout the world and throughout the geological column.
Yeah, and it seems to me that the more data we collect, the scientists collect, in other words, the sample sizes grow, and the methodological rigor of that carbon-14 sampling and then the calculation of the dates is done also improves over time, right? So yes, eliminating things like contamination, yeah, and there's some calibration that's been worked out. You mentioned this tying into tree rings in your book. So those factors are there too. So it's not like we haven't seen great improvement.
No.
And the cases you document, these are all in secular publications. Yes. So this isn't like, no, us crazy religious people, we don't know what we're doing. We're biasing the information. This is from a wide array of data. And you mentioned throughout many places in geologic column and ubiquitously from a geographical standpoint. Is that right? Do I have all that correct, Dr. Walton?
Yes. Mm.
Now, what is that as a rigorous organic chemist? That kind of information. Tell me how that appeals to you from a scientific standpoint. Does that point more strongly in the direction of the way that you like to see science done? You know, the more rigorous, the more data, that kind of thing.
Definitely, yes.
I think you get what. Yeah.
Yes, I agree. And again, if you get information coming in from unrelated areas, you know, this again is very persuasive. I think more persuasive than if you just keep on piling up the same kind of thing, you know. And we're going to talk about the soft tissues in a minute, aren't we?
Yeah, because these are closely related with one another, the soft tissue issue, and this is even more in the wheelhouse of your specialty.
Yeah.
Although, you know, the thing is about this carbon-14 thing is to me, I just feel like this is one of the strongest scientific arguments that there's something seriously wrong with the whole deep time construct.
Yes.
And I know people listening that are committed to deep time, whether maybe we have some folks out there who are skeptics, atheists, probably mostly Christians listening, but maybe of an old earth persuasion. This has to be explained, the presence of all this carbon-14. And from what I hear you saying is the contamination explanation in whatever various ways you want to cover, it just doesn't cut the mustard.
Yeah, absolutely. Yeah. And I just can't. I mean, you know, if you talk to secular people, they say, oh, well, it's contamination, end of story. But they have no explanation of where the contamination came from. And it's interesting also to note that you get the same quantities of radiocarbon in specimens from Stone Age and Pleistocene era fossils. Things from Aurignacian, Emirane, Mousterian cultures, you get the same amounts of radiocarbon in the same range. You know, I talked about 0.5 to 0.2. They're in exactly the same range for those cultures. Same as those observed for coal samples, for example, from hundreds of millions of years ago, and also in dinosaur fossils. But the genuineness of these results goes unquestioned. Anthropologists consider those dates, the Stone Age dates, as historically accurate on the same quantities of radiocarbon.
Yes.
It's kind of ironic, isn't it? That when you dismiss it as contamination when it's found in a dinosaur fossil, but if it's found in a Stone Age fossil, the same amount, then the age you get from it is reliable. I think that's illogical, it's contradictory, it's an incoherent practice.
Yeah, it really does lack it lacks a consistency. I don't see how you can get around the inconsistency. It's so interesting. You're in the book you specify. I'm just kind of reiterating what you just said, but so the amount of carbon-14 that remains in the samples is pretty similar.
Yeah.
So you got the amounts that are in materials from the geologic column that are tens of millions or even hundreds of millions of years old. Same amount in so-called Stone Age remains.
Yeah.
The Stone Age dates are accepted.
Yeah.
The other ones are rejected. And there's no explanation as to why one is legit and one isn't.
Absolutely, exactly. Yeah, yeah.
And this speaks to you as from a scientific standpoint, from your experience of just, again, this lack of a methodological consistency and rigor. If these dates are truly reliable, then the data should be consistent within the paradigm itself.
Yeah.
That's how I view that. What are your thoughts about that?
Yes. Well, it's a case, isn't it, of a confirmation bias, you know, and of letting the theory the theory of deep time and evolution determine what you will accept and what you will not accept. Here, they don't want to accept the younger dates for dinosaur fossils, for example, or coal seams, and so it must be contamination in that case. Whereas they do want to accept the long dates. Well, the 57,000 or 100,000 dates for Stone Age samples, for Neanderthals and so on. And so they're happy with the fact that they're happy with going along with the fact that it isn't contamination in those cases. You see confirmation bias very much in evidence there.
Excellent. Well, we're going to shift our conversation to you came up with this great term in your book, the giga catastrophe. And you mentioned here a couple things I just want to survey before we move to the giga catastrophe. Talked about the problem of water leaching for the radiometric dating methods, the failure of dates for rocks of a known age, rocks that are only decades old, yielding dates that are millions of years. 4 methodologies sometimes used, highly discordant dates, and then the carbon-14 found in coal, dinosaurs, and diamonds. You document all that. Diamonds are supposed to be billions of years old.
Yes. Yes.
And here we find carbon-14 in there. That is just so fascinating to me.
Yeah.
But I don't want to belabor that because I don't want to cover too much, Dr. Walton, because I want people to buy your book and read all about it.
Okay,
so tell us about tell us about this term that you use here, the giga catastrophe.
Yeah.
I know that scientists are more on getting on board with local catastrophes, explaining some of the geologic column. They're not giving up their deep time paradigm, but you point to what looks like something much more substantial.
Yes, indeed. Yeah. So the radiocarbon data suggests that fossils from every stratum, really, in the geologic column were all buried comparatively recently within a short space of time. And, the geologic column is global. There's a similar pattern everywhere. So that implies a gargantuan catastrophe of world-embracing proportions. As you were saying, Earth scientists are admitting a lot of individual catastrophes now. There are the really enormous sedimentary sequences, like the chalk cliffs of Dover, for example. Everybody's heard of the white chalk cliffs of Dover, and yet the same formation extends into Ireland, across Britain, into Ireland, and across the Europe, right across Europe, across Turkey, into is it Azerbaijan, somewhere like that, and then it can be traced in the Midwest of America. The very same formation with the same kinds of fossils in it, and then the same sedimentary layers above and below. And then there are the enormous fossil graveyards. There's one now. Where is it? Well, there's literally billions of fossils of fish in a fossil graveyard. I'll remember where it is in a minute. And there are lots of fossil graveyards all over the world. As I say, marine creatures and all fossilized together, all buried together, and it extends over something like 10,000 miles. Not 10,000 miles. It must be 10,000 acres. Anyway, it's an enormous 2 states of America. Would that be acres or what? Anyway,
miles.
This whole thing's miles. It extends over 2 states of America. There's so many fossils buried in it. There's nothing like that happening today. And of course, there are igneous formations as well, like the Deccan Traps, that are similar size as well. Now, and then there are 5 major extinction events. There are supposed to be 5 major extinction events where almost all the life on Earth was wiped out. Now, if you put all these together, you get this, what I call a giga catastrophe. Dr. Timothy Clary, wrote a fascinating book about this. He called it Carved in Stone. And he draws attention to the megasequences, the Sloss megasequences that are sedimentary megasequences, but they are as big as whole continents. The same sedimentary sequence extends across a whole continent and beyond,
Yes.
as I was explaining with the White Cliffs of Dover. I mean, that isn't a sequence, but it's a stratum like that. He finds 6 or 7 mega sequences that make up the whole geological column. So that's what I'm talking about when I say the giga catastrophe caused that.
Yeah, these features, I mean, there's many things to say about that. One of the most intriguing things for me has always been these, what you're kind of getting at, is these transcontinental features. They're not just continent wide, in some cases hundreds of thousands of squares. If you'd like me to convert to kilometers for you there, Dr. Walton, we can do that. Hundreds of thousands of square kilometers and across multiple continents, and sometimes by continents that are separated by the ocean. So there's something extremely catastrophic that's taken place here that's interconnected. Now, folks, if they want to expand further on this, they can check out some of the end notes in Dr. Walton's book and other episodes of Digging for Truth, where we've gotten into the details of this with Dr. Andrew Snelling and about the scope of these features. But this giga catastrophe does have an impact on carbon-14 dating. So, on one hand, we're kind of using it. If you take the assumption that it's correct all the way down to the 60,000 years, which is what the conventional paradigm would assume. They would assume that it's pretty much a sort of a uniform decay. There's some anomalies, but basically it could be extrapolated backwards.
Mm-hmm.
Within the conventional paradigm, the carbon-14 shows that the geologic column has been misdated. But on top of that, you believe, and I agree with you, that there also needs to be some recalibration with the carbon-14 dating as well. And that's part of what you're doing in your book. You're saying you're not just critiquing the old deep time framework, you're offering an alternative recalibration. So tell us about that, if you would.
Yes, I think that's a very important point. The radiocarbon dates for dinosaur fossils and coal seams that we've mentioned, they're orders of magnitude younger than conventional geologic column, but I mean they're in the range about 30 to 50,000 years, and this is quite a lot older than Genesis suggests. Could there be a reason behind this? And that's what I've been trying to do in my book, and of course I've been following others. In radiocarbon dating, the measured amount of radiocarbon in the fossil, that's what you determine experimentally with AMS spectrometer, that's compared with the present amount in the biosphere. And then the uniformitarian assumption is that the present amount of carbon-14 in the biosphere has remained about the same. There are some minor changes, and these are allowed for, but it's the same into the far past. But this ignores the gigacatastrophe, the global flood event. And that's a great discontinuity that would make a huge difference to the carbon-14, the radiocarbon in the biosphere. And this needs to be taken into account if you're going to arrive at a true date from the measured carbon-14 quantities. And the geological evidence shows that the biosphere before the flood was very much larger than it is today. Enormous amounts of biomass were buried in the coal beds, huge extensive coal beds on every continent. More carbon was buried as gas and oil, huge ones. There are carbonate rocks, chalks, shales, similar rocks, all derived from biological materials. Now, based on these vast carbon reservoirs, scientists have estimated that the biosphere would have been somewhere between 200 and 700 times larger, more luxuriant before the flood than it is at present. So say take an average value of about 500, then it follows that before the flood, the radiocarbon in the biosphere would be diluted by a factor of 500. That means it would be about 0.2% its present level. And this needs to be taken into account when calculating the dates by radiocarbon that are near the time of the flood, during or shortly after the flood. I say it at least 500, incidentally, because carbon-14 is formed when cosmic rays bombard nitrogen in the atmosphere.
Right.
And there were probably less cosmic rays reaching the surface of the Earth too in the past, because we know that the Earth's magnetic field is decreasing at about 6.3% per century at the moment. So after the flood, the amount of carbon-14, radiocarbon, in the biosphere would rise rapidly, fairly rapidly, to its present level. And this needs to be taken into account in getting dates from radiocarbon dating near the time of the flood. And it means that dates that are calculated for that era would be too old, significantly too old, if there's less radiocarbon in the biosphere. So the raw radiocarbon dates for Stone Age and Bronze Age specimens, just before the flood, they come out about between 30 and 50,000 years old. True dates would be much younger.
Yes.
If the smaller amount of radiocarbon in the biosphere was used in the calculation. And in my book, I explain how this could be done. Shall I talk about that? Or
yeah, that would be great. I think that, obviously the recalibration is a big part of your thesis, right? So go ahead. Any direction you want to go in, go for it.
Well, several scientists have suggested ways of calibrating radiocarbon data to allow for those effects. And Dr. Robert Brown of the Geoscience Research Institute at Loma Linda University, he devised a comparatively straightforward, a simple-ish method of doing this. He assumed that the amount in the biosphere would rise after the flood from its pre-flood amount to that of today by an exponential curve. And he made reasonable estimates of the parameters for this curve. Using his method, it's possible to recalibrate carbon-14 data from the professional literature again to allow for the flood discontinuity. When this flood method, I call it the flood method or Brown's method, is applied to published amounts of carbon-14, it demonstrates first that radiocarbon ages for specimens from today back to about 1000 BC, or maybe a little bit before, would be unaffected. They'd remain the same. And that agrees well with what we know about carbon-14 dating. When it comes to antiques, specimens like the Dead Sea Scrolls or the Vinland map, it's very good. But for earlier dates, before about 1000 BC in the Bronze Age and Stone Age, Brown's flood model predicts progressively younger dates than conventional carbon-14 dates. Younger. Is it reliable? Well, I think a good test is a comparison of the flood model dates with dates obtained from historical and archaeological data that are independent of radiocarbon dating. And historians and archaeologists, you're one yourself, so you know this, have developed chronologies for the ancient Near and Middle East by very careful, meticulous comparisons of pottery, inscribed tablets, king lists, monuments, astronomical data, and so on. They're not infallible, but they give pretty good estimates of the true dates of things. And it's worth noting, first of all, that historians and archaeologists have been saying for decades that there's something wrong with carbon-14 dating for specimens from before about 1000 BC, Bronze Age specimens. They're too old. I can give you some examples. Israeli archaeologist Amihai Mazur, he refuses to use carbon-14 dating for Palestinian archaeology for remains from the 3rd and 4th millennia BC. He's in print as saying that. Egyptologist Herbert Haas reported Egyptian Old Kingdom radiocarbon dates are 374 years older on average than these historical dates. David Roll found carbon-14 dates, and earlier from Egypt, they require 120 years of extra Egyptian history for which there's absolutely no archaeological evidence. Hendrik Bruins, Van der Plicht, don't know how to pronounce their names, reported radiocarbon dates for early Bronze Age Jericho, 100 to 300 years older than conventional archaeohistorical time estimates. Archaeologist Arthur Knapp I probably don't need to go on, but he said dates deviate increasingly from actual calendar dates, that's historical archaeology dates, from a 200-year era, about 1000 BC, up to a 900-year era, about 5000 BC. So to put the flood model to the test, we need cases where there's both a historical date from archaeology and a conventional radiocarbon date, an uncorrected radiocarbon date. And my book, Compact Time, shows a graphical comparison of a good selection of these such dates. And I believe there's a graphic that accompanies this podcast, which shows that graphic.
Yeah, we're going to put that in the description so people can see that.
Yeah. On that graphic, the historical dates from various sites in Egypt, Jericho, and other ancient Middle East sites, they're shown as coloured markers. Then the conventional carbon-14 dates, uncorrected by the flood, are the straight dotted black line. And you'll see that this black line shows dates getting progressively older than the historical data and out of touch, leading to empty centuries of history, just as the historians and archaeologists reported. Now, on the other hand, Brown's flood model, the one I've been describing, is shown by the curved purple line, and it fits the historical data quite well. It's not a perfect fit, so it's a simple model, but it does fit quite well. Both the historical dates and Brown's flood model dates curve towards an asymptote about 5,300, 5,400 years before the present. That's about 3,300 BC, 3,400 BC. And that would be the date of the gigacatastrophe or global flood.
Right.
To me, that's rather impressive evidence favoring this flood model for carbon-14 dating.
And as time goes on, too, the more data that's collected, the more it can be plugged into this to see, does it fit the curve? What adjustments do need to be? What kind of calibration needs to be done? It's really interesting. So you've touched on so many things there. That's our experience. There's something discordant about what's going on in the Bronze Age, especially the early Bronze Age. Archaeologists have said, look, the historical data is off. There's a disjunct.
Yes.
What's interesting, of course, is the secular model. Once you start getting into the so-called Stone Age, they don't continue to see that because because of the deep time paradigm and the evolutionary development of man. But you point out in the book, there's these like empty centuries where you've got people living for thousands and thousands of years, and there's just not any remote enough material culture to match up with any of that. That is an excellent point. So while the book is largely scientific, you're also bringing in some of these other pieces of information because they're relevant to the discussion.
That's right. Radiometric dating using potassium argon and uranium lead and rubidium strontium and so on. There are 200 centuries for Stone Age and Pleistocene people groups with virtually no cultural changes. It's an immense time period, and all that happens is a few changes in their stone tools. They're hardly different from those that are still employed by some modern humans in various areas. And we know that the Neanderthals of the Mousterian culture, for example, were fully Homo sapiens. They intermarried. That now DNA has shown that they intermarried with modern Homo sapiens.
No doubt.
And yet they lived, and then suddenly about 3000 BC, human activity explodes into a vast array of changes. Every aspect of life, ethnic makeup, agriculture, building, textiles, writing, languages. For 200 centuries, practically nothing changes except stone tools and leather and so on. And then suddenly there's this amazing contrast. And of course, that all disappears with the flood model. There's only about 300 years for that time period, the Stone Age time period, from about 5,300 years before the present to about 5,000 years before the present.
Yeah, it's so interesting. One one of the things we've talked about at ABR is getting some people on a research project to see. So if you have 1 meter of strata at a conventional archaeology site, like Shiloh, where we're digging, and you have a general passage of time based on the pottery typology, let's say it's 2 centuries, just for the sake of discussion.
Yeah.
Why is it a similar meter of strata at a Stone Age site is 20,000 years? Why is that the case? It would be, we haven't done that research, but like intuitively, I would like to see like a comprehensive study of that to see the differences. Like, why would we think that 1 meter or even 2 meters of strata would be that long? And this goes to the point you make in the book about these empty centuries of Stone Age time. It just doesn't make sense. And the evolutionary model really can't explain the explosion of civilization. The flood model explains that.
Yes.
Much better.
Yeah.
Much better.
Yeah, that's right. I'm very interested that you said that. You know, I'm not an archaeologist, but I've often wondered if that was the case. Of course, there'd be some compression if the strata above are on top of these earlier strata. But
sure.
You're saying that, you know, it's really enormous, the difference in, you know, 1 meter representing, say, a few hundred years, and then 1 meter representing thousands of years. And you're not going to be able to attribute all that just to compression from the weight of overlying strata.
Yeah, and that would be a general average, you know, because strata it's a lot more complex than just a layered cake. So, you know, the way that people live, you have erosion, you have destruction, you have all kinds of variables in there. But the idea is why the disjunct? And it's because the evolutionary model, the long age model, drives the interpretation of the strata. And so, you know, there is an interrelationship within the paradigms themselves, right?
Yes.
So it has to be a longer period of time, and it kind of has a back, you know, kind of feedback loop, if you want to maybe say it that way. It's really fascinating. We're hoping here at ABR that God will raise up a generation of archaeologists who are willing to study this era, because it hasn't really been the pre-Abrahamic era hasn't been studied very much from a recent creation compact time perspective.
Right.
So if you're out there and you're younger and you want an area of archaeology and science that you can explore that hasn't been explored, this is the area here. Is the sky's the limit.
Yeah.
Now I'll mention briefly, we're not going to delve into it because I want to move to dinosaur tissues and that kind of thing. I'll just mention in your book that you have a chapter on worldwide flood stories.
Yes.
And even though that's not a scientific treatise, it's part of the evidence. Yes. Why do we have all these cultures that speak of this global event and has commonalities with the Genesis account and fits the Giga catastrophe? So we want people to check that out. Compact Time, Dr. John Walton, pick it up at Is Genesis History, and you can read a little bit about these flood accounts. But I would like to, and I'd love to talk about that. But I do want to move to the soft tissue question. We on Digging for Truth TV and podcast have talked about dinosaur tissues before with other scientists, but you have a unique perspective here because organic chemistry is your wheelhouse. You've published hundreds of papers. You've been doing this for decades. Let's talk about these tissues in these fossils, dinosaurs and other creatures. Whichever way you would like to go, Dr. Walton.
Yeah, well, you probably know that they were first discovered. Well, they first came to attention through the work of Professor Mary Schweitzer, and she attended a lecture by Professor Jack Horner. You know, he was the inspiration for the paleontologist in the film Jurassic Park. And he persuaded her, she used to be a young Earth creationist, but he persuaded her that evolution and deep time were true. And she went to work in his lab, and she was sectioning a Tyrannosaurus fossil, and it was said to be 68 million years old. But under her microscope, she saw circular red structures that looked just like red blood cells. And she showed them to Prof. Horner, and they both agreed, no, this is impossible, you know. Every paleontologist, every scientist knew soft tissues, fragile protein blood cells, they quickly degrade, they fall apart. They can't last 68 million years. She and Horner tried for a long time to prove that they were contamination or something, but no, they failed to do that. And then in about the year 2000, they started publishing their results. And she has beautiful pictures in her papers of red blood cells, bits of tissues. There are impressive photos and videos of these things stretching. You know, there's still little bits of meat there in the dinosaur bones, stretchy skin, blood shells. They ran into a terrific storm of criticism because paleontologists knew, or they feared right away, that if this was true, then dinosaur fossils couldn't be millions of years old. Some said they couldn't replicate her results. Some said it was contamination. Others, it was biofilms from modern bacteria. Anyway, eventually she had her own lab at North Carolina State University. She published lots more papers. She completely refuted all her critics, discovered many more fossils containing proteins, soft tissues, collagen, even DNA. Her findings were completely vindicated. Nobody doubts them now. And it's just the tip of an iceberg. Lots of other people started discovering them. Dr. Mark Armitage got a triceratops horn, which is loaded with soft tissues. He photographed osteocytes, bone cells in there. Dr. Phil Wilby, searching a Jurassic formation, supposedly 150 million years old, in a dig here in Wiltshire in the UK, found amazingly preserved crustaceans, including a tiny fossil squid, and it has a perfectly preserved ink sac. The picture was published in his journal article and in newspapers, and then somebody rehydrated the ink, and an artist published a picture of the squid with its own ink. It's an incredibly tall order to believe that the ink, it's not carbon black. It's a delicate mix of proteins that survived fresh for 150 million years. Chemistry doesn't last 150 on proteins, doesn't last 150 million years. There was a review article by Thomas and Taylor, and they listed 85 papers reporting the detection of more of these things in fossils of many types, not just dinosaurs. I'll read you. They said, these intact biological remains have been found in fossils of all taxa from all the biological kingdoms from most continents. And then a more recent count lists 120 reports in more than 30 different science journals, soft tissues, protein discoveries in dinosaur and other fossils. So, the evidence is overwhelming. It seems to be everywhere in the geological column, and more reports, more and more are being discovered all the time. There's a whole sort of subject area on ancient proteins and ancient DNA. Paleo proteins is coming about as a result of that. And then DNA traces as well. I mean, think of that DNA, which is far more fragile than proteins. You were saying about me being a chemistry professor. Yeah, there've been lots of studies about how long these things could actually last in a lab. I mean, they've taken some into a lab, like collagen, for example, which is protein associated often with bone, and subjected it to heat and various degradative processes. And they found that even under the most favorable conditions, freezer temperatures, completely dark, no moisture, absence of oxygen, then the toughest protein lasts less than 1 million years. And of course, in the ground, in rocks, where fossils are exposed to oxygen and groundwater, 20,000 years is a more realistic limit about how long these things, certainly collagen could last. And of course, DNA would last less than that.
So this obviously appeals right at the heart of your expertise. Now, I'm a non-expert here, but the sort of intuitive response to all of this is, yeah, that doesn't seem plausible that it could last that long. But you just pointed out that scientists have created ideal circumstances that actually don't occur in nature. Mm-hmm. They actually don't occur. It's maybe someplace in Antarctica, maybe you could try to do that, right?
Yeah.
Like really cold in Antarctica, but like they're creating these ideal conditions
Yeah.
and just can't create the kind of conditions necessary. I mean, you think about that Triceratops horn, it was only like 2 or 3 feet from the surface in
Yeah.
Montana,
Yeah.
which has high fluctuations in temperature. Maybe just address that generally speaking, and then your experience with dealing with organic materials in the laboratory and how sensitive they are and
They have to be loaded.
how easily they're destroyed.
Yeah, I mean, biologists constantly complain about their proteins going off and degrading all the time, even under lab conditions. And, developing new antioxidants and new preservatives is a huge area of research. I even did a bit of research into antioxidants myself. There just isn't anything available. Foods carry sell-by dates and use-by dates and so on, and they're usually only a few years. It's the same with medicines. The paleontologists have suggested that there must be special methods of preservation, iron particles, for example, or another thing called the toast method, Maillard chemistry, which is supposed to cross-link the proteins and so make them longer lived. No food scientist, no chemist is investigating any of those methods because they know perfectly well none of those things would extend lifetimes to millions of years. Okay, you might possibly get a few extra years that way, but not millions of years. If somebody discovered a preservative that would extend lifetimes of food products, proteins, or anything, even for hundreds of years, they could make a fortune. And of course, they could put an end to world hunger. I mean,
they'd be rich. They'd be richer than Jeff Bezos of Amazon. I mean, that would be a world-changing type of preservation. This is such a great point, Dr. Walton.
Yeah.
In the experience of everyday life, we just know.
Yeah.
But when it comes to regular everyday food, I mean, I go to my refrigerator and I'm looking at the expiration date going, that was yesterday. Should I eat that? I smell it, like that kind of thing. Right. I mean, you just know that these things just have a relatively short shelf life.
Yeah, absolutely. Yeah. Yeah. I mean, literally thousands of tons of food are thrown away every year. If we could only find a preservative that would enable us to extend those lifetimes, as I say, world hunger could be ended, but it's not happening.
So one of the things you mentioned earlier when it came to radiometric dating was the problem of leaching with water. Maybe talk about, as an organic chemist, about water is the enemy of all of this, right? And water is ubiquitous and pervasive everywhere on planet Earth, like everywhere.
Yes.
Water gets into everything. Just think about like you get a leak in your roof and you can't figure out where the water's coming in, right? That's a very simple example, but talk about water as the enemy of organic anything and just its pervasive nature.
Well, you've already said how pervasive water is. All rocks, on geological timescales, all rocks are porous in terms of water. It's a very small molecule, so it gets in everywhere. It's only H2O, hydrogen, oxygen with 2 hydrogens on it. It's very small, gets in everywhere, and it hydrolyzes things. Molecules like proteins, water will hydrolyze them back to their amino acids. DNA, water will hydrolyze them back to their component parts. It's the same with fats and lipids. Water hydrolyzes things back into smaller components that are then water soluble and get dissipated around. Even really things that you think are really solid, like glass and flint, for example, water does penetrate them on a geological time scale. So, talking about sequestering fossils in cavities in rocks isn't going to help. The water is always going to get there eventually. I think it's relevant also to mention oxygen, because oxygen is another small molecule, and in some ways it's even more damaging than water, because oxygen oxidizes things. Everything oxidizes quite rapidly by the oxygen that's in our atmosphere, and it breaks down carbohydrates, it breaks down lipids, it breaks down proteins into their component parts. Eventually, almost everything ends up as carbon dioxide or oxides of nitrogen or the other atoms that are there. So both those molecules are small. They get in, they penetrate. Quite often there are catalysts. Minerals will catalyze the hydrolysis process that you were mentioning a few minutes ago as well. That will make it quicker. So, water and oxygen, microorganisms as well, but they're a bit bigger. So, generally speaking, than those molecules. But those are really, as you say, the enemies of preservation of soft tissues and the like.
Yeah, that's a good summary. I wanted to let you do your thing there and just explain that a little bit, because I think people really need to hear. Like, now, I kind of understand, and maybe we'll wait. I'll give you a chance here to wrap up. We're coming down to the end. And on one hand, I can understand the conventional scientists discovering this stuff and then saying, well, we know that these things are 65 million years old, et cetera, et cetera. So let's try to find a mechanism that can explain that. That's good science in the sense of, you think this is an established fact. Now we need to find something that's consistent with it.
Yep.
The problem is they haven't found anything that's remotely consistent with it, but haven't drawn the line to, maybe I need to reconsider the paradigm. And this is a worldview issue and a religious, spiritual issue beyond the scientific issue. Maybe if you could comment on that.
Yes, it is, isn't it? It all comes back, down to confirmation bias. You don't want to change your world view, do you? You won't give it up very easily, and you tend to forget about, you tend to discount. You're in denial of things that don't mesh with it, or you simply say, well, science will find the given time. Science will find the answer, and I think that's what many paleontologists are doing at the moment. They're just hoping that somehow. Well, if you read Wikipedia or something like that on this very topic, they talk about iron particles, which was Professor Schweitzer's suggestion, and Maillard chemistry, and sequestering the soft tissues within pores in rocks and so on. And they're just hoping and hoping that science will turn up a possible answer to explain how these things could. As a chemist, I can't see. There's so many orders of magnitude difference between what science currently knows and the length of time that these things are supposed to have survived. There's so many orders of magnitude that I don't see it happening.
Yeah, it's interesting. They're expressing a confidence, a hope, a faith in some future set of circumstances that will vindicate the present belief system that they have.
Yeah.
That's not very scientific.
No.
That's religious and philosophical, isn't it?
Yeah. When it comes to the radiocarbon dating, they're simply refusing to date fossils that they know are pre-Pleistocene by radiocarbon. They simply refuse to date them now, and they send the samples back and say it's anti-science to date such a thing by radiocarbon.
Yeah, certainly not the way we want to conduct scientific business. We should be in the search for truth, right? Like let's dig for the truth and let the evidence show what it is, and why be afraid of it? Certainly from a standpoint of, I believe the scriptures are from God, God's revelation, God speaking. God speaks accurately and inerrantly. It's impossible for him to do anything other than that. And therefore, I have good reasons to encourage scientific exploration and not be afraid of whatever we turn up under the stones, as it were, So to do that really is not good for the advancement of good scientific work and the search for truth.
I couldn't agree more. I couldn't agree more. It's not anti-science at all. It's just anti the evolution and the deep time explanation, and that doesn't constitute science. I think that's soft science, as we were talking about earlier.
Yes. Dr. Walton, I'll give you an opportunity to sort of wrap up the show, maybe summarize our discussion. Take a couple minutes if you like. I'll let you do that any way you like to.
Okay. Well, we talked about the radiocarbon dating. There's very good reason to believe that the radiocarbon shows that the geological strata are very much younger, thousands of years rather than the millions of years of deep time. Then the soft tissues that have been discovered in dinosaur fossils, in coal measures throughout the geological column provide very interesting supporting evidence for the much shorter timescale, the compact timescale that's mentioned, the young Earth timescale that many conservative Christians believe in. The sedimentary megasequences suggest that the entire geological column was deposited in a short period of time in a huge flood, similar to that described in Genesis. And then the amazingly widespread folklore describing a flood, a global flood, again, is more supporting evidence. Now, you notice that that's 4 different areas from completely different areas of human activity, all converging into the one area of suggesting a huge flood thousands of years ago. They're independent approaches to the same thing. It's not just repeating more and more radiocarbon or whatever. 4 different approaches. They all support a young Earth compact time chronology from the primordial history of life on Earth. And there are actually a lot more lines of evidence as well that we don't have time to talk about. So we need to rid our minds of deep time conditioning, the conditioning that we received in school or university. The evidence is strong that the Genesis account can be taken as real history when properly understood, without the naturalist bias. Science is in harmony with Genesis. It can be harmonized with Genesis as history. The New Testament Gospels record Christ speaking of the flood and of other things happening in Genesis. They speak of them as real and historical. So evidence for Genesis is also evidence for the reliability and authenticity of the New Testament Gospels, for their moral teaching and their teaching about Christ. We can also believe that if we can believe Genesis. Genesis describes God creating humankind instantaneously at his word. He didn't need millions of years of evolutionary suffering or death, according to Genesis. Since God created in a day, we can have confidence that he can recreate also in a day when he returns. That's such a message, I think, of great hope for all humankind.
Excellent. Dr. Walton, thank you for that final word. We stand on the rock of Scripture, the Word of God. Scripture speaks, God speaks, and the mission of Jesus to restore that which has been broken and fallen. Appreciate your being on. Thank you for your work, and thanks for being with us, Dr. Walton.
Thank you too, very much indeed.
Make sure to pick up a copy of Dr. Walton's book, Compact Time, Radiocarbon Dating, and the Case for Young Earth. And we've got a link to it for you in the show notes. And that's all we have for today. Thanks for listening.
Digging for Truth is a presentation of the Associates for Biblical Research. To find out more about ABR, just go to BibleArchaeology.org.